So today we're going to be looking at partial fractions. Let's start with our first problem. X squared plus x plus 2 all over x plus 1 and x squared plus x plus 1. Now before you start your partial fractions, first we have to do some analysis. Our first point of analysis, whether it's a proper fraction or whether it's an improper fraction. Our second point of analysis is observing the denominator. So here on the bottom we have a linear and non-repeated factor in x plus 1. Non-repeated, there's only one of it, and linear, which tells us that x can't be equal to -1 as a solution. And looking at our other denominator over here, we can see that it's a quadratic. However, this quadratic can't be factorized. Therefore, for this fraction, you can either do one of two things. You can either A, solve by algebraic or long division, or B, you can use partial fractions. Today we're going to be looking at the partial fraction method of solving. So let's do it. Let's solve this fraction and express it in partial fraction form. So we can say that this whole fraction has to be equal to the following expression: ax plus b over x squared plus x plus 1 plus c over x plus 1. This is the most common form of expression for a quadratic that can't factorize. And our other constant here is over this denominator right here, c over x plus 1. The reason we're using the constants a, b, and c is because we're going to be comparing coefficients later. But for now, we have this equation, and let's start solving for it. Let's start breaking it down. So we multiply by the denominator on the left hand side. So on our right hand side, we'll actually have the expressions of ax plus b. The bottom denominator cancels, and we have a numerator in x plus 1. And here the bottom denominator also cancels, and we have a numerator in, oops, sorry, wrong color, in x squared plus x plus 1. Now here you also have two different methods to choose from. We know that x can't be equal to -1, -1, sorry. So you can just substitute -1 in, and you can compare. Or the method that we'll be doing today is by comparing degrees of x. What I mean by this is this notation stands for the constant. And here we know that on our numerator, on our left hand side, all that remains is our numerator, x squared plus x plus 2. Since we multiplied through by the denominator to get this bottom equation here earlier. And our only constant on the left hand side is the number 2. So according to our partial fractions, we need to gather the like terms which don't have an x variable in it. So we take this a of x, we see that that makes an x squared, that makes an ax, so that's useless to us. We take this b, that makes a bx, but however, this makes a b, that's going to contribute and add to the constant. Here, cx squared, nope, that's just a quadratic. Cx, nope. C plus 1, yep. So we can make an equation of b plus c being equal to 2. Let's consider our second degree. Now we're going to be only considering like terms with x. So here we have x and 1. Yep, that will contribute. So that's going to be a. Here we have b and x. Yep, it's also going to contribute. So we have a b. And here we have a c and a 1, I think. So that's also going to contribute. And this expression will equal 1, as we only have one x above. And for our third degree, the x squared degree, we collect like terms once more. We have ax and x, that's ax squared, so that's an a. And the only other x squared I can see is c and x squared, cx squared. So that's a plus c being equal to 1, because again, coefficient of 1. Now, we have these 3 equations that we've formed, and you can immediately see that this equation here, a plus c being equal to 1, that can be substituted into the equation above. And what we will get there is b plus 1 equals 1. So let's make some more space. And therefore, we know that b has to be 0. Now we can see on the bottom equation that 2 equals b plus c. Therefore, we'll know that c has to be equal to 2. And earlier, we said that a plus b plus c has to be equal to 1. So a plus 0 plus 2 is 1. Therefore, a will have to be negative 1. So now that we have our 3 coefficients, we can now display it all and express it in partial fraction form. So for x squared plus x plus 2 all over x plus 1 and x squared plus x plus 1, all of that is going to be equal to our ax plus b, and we've established that a is minus 1 and b is 0, so we'll have a minus x all over x squared plus x plus 1, and here we had a c over x plus 1, but we've seen that c is equal to 2, so 2 over x plus 1. And this will be your final answer.